Hello all, this video is on Arduino IoT Cloud, an application platform like Blynk to control devices from anywhere. Both Blynk and Arduino IoT Cloud provide free plans as well as paid plans. Arduino IoT now support third-party boards like ESP32, but Blynk supports a huge variety of hardware including Raspberry Pi. If you check up the pricing and plans of IoT Cloud, Arduino IoT Cloud, they offer for free only two things. That is, thing is the basic unit in an IoT, and you connect devices to thing. And they offer only 5 cloud variables, 100 MB of sketch storage, and 25 compilations per day. But for free plan, they do not offer over-the-air update. Over-the-air update, where you do not connect the USB of your hardware. Over Wi-Fi, you update the sketches. That is very convenient, but it is in IoT Cloud only for a paid plan it is offered. But if you check up the plans in Blynk, for a free plan they also offer only two things. That is, two devices can be connected, but they offer over-the-air update for a free plan also. Arduino IoT Cloud is in initial stages. They mainly support Arduino boards and ESP32 third-party boards. Now let us sign in the Arduino IoT Cloud with the Gmail account, and then click on IoT Cloud. On the top you can see some tabs: things, dashboards, devices, and others. Before getting started, you have to install Arduino Create Agent. That is a small software program that works on background, which provides interface between your local USB port and the cloud IDE. This is very important. So you have to first install the Arduino Create Agents. Download the Create Agent and then follow the installation procedure. This Arduino Create Agent recognizes the Arduino board connected to your PC USB and helps uploading sketch from web browser to your board. So this works in the background. It starts up automatically when you open up your machine. It runs in the background. Once it is installed, and at the bottom you can see the icon where you have pause agent, quit agent facility, and open debug console and go to Arduino Create. So it runs in the background. Now let us go to the main IoT platform. Before creating thing, go to the devices. You have to connect the ESP32 device first to your PC, and then under add device, click on set up third-party device. The first tab is for setting up Arduino boards. They support only NANO33 IoT and MKR IoT boards, advanced boards, and recently they have added this third-party device support. So click on ESP32 and then select the module as ESP32 development module. Provide a device name, that is provided as ESP32 underscore IoT, and then you get on secret ID and device ID PDF download link. Download this PDF file and keep it safe. So you'll need this secret key and device ID while programming. Your device will be recognized only against this secret key and device ID. Now click on continue and then done. Now you can see the status. Your device is offline, and now click on create thing. Under create thing, you can associate a device, provide the network credentials and cloud variables. You can create variables. First you provide a title. Let us provide ESP32 underscore LED test, and then first click on configure network. Provide your Wi-Fi, local Wi-Fi name, and then the password of your Wi-Fi. and then the secret key you received in the PDF file. Copy this secret key and provide it here. It will be automatically included in your sketches. Next, you have to associate the device. Now we have associated the device and then the network. Now you can see your skeleton sketch has been automatically generated. Click on the sketch tab and you can see the skeleton of the sketch generated. We have not created any variables, so there are no variables and functions generated. It is only a skeleton sketch. Go back to setup and then click on add variables. Now let us create some variables. For LED switching on, let us create a switch. Name it as LED_switch and we select the basic type of variables. Now under basic type of variables, it is now let us select Boolean. So it is on off only, so we will select Boolean. Automatic declaration is generated, bool LED_switch, and select the variable permission as read and write. As it is output device LED, we select read and write the permission. This is the first cloud variable. Again you click on add. Now let us create a second variable for LED's fading effect, that is PWM. LED_slider. We'll give it a name. Select the basic type of variable type, integer. The declaration is auto generated, int LED_switch. Variable permission is read and write, and the variable update policy is on change. And finally click on add and then add the third variable name, that is a messenger. That is a messenger between the your desktop and your mobile app. Let us select it as character string. Now we have created 3 variables. Now go to the sketch and check out the skeleton sketch. You can see the variables we have created or mentioned on the top. And if you scroll down, you can see the thing properties.h header file is automatically included, and under setup and wide loop you can see the Arduino Cloud.update functions being called. And finally these functions are all automatically generated. That is we have created a first variable as LED_switch, so that name has been used, and the previous on change has been added in between. So any change in the variable will be called by a call to this function. You can also use the full editor. On the top you have that tab open full editor. It will go to the full editor mode where you can see the library manager. Most of the libraries are pre-installed on cloud. You need not install any library. At the right hand side pan you can see the skeleton of the sketch as well as the readme document, and thing properties.h header file, and finally a secret.h header file where you have provided your Wi-Fi credentials. Now let us go back to the IoT Cloud editor and then upload the code. On the top you can see verify and then upload a symbol. Before that you have to confirm that the port has been selected correctly. As OTA is not available for ESP32, select the COM port where you are connected ESP32 and then click on verify and finally upload. Now let us wait for the upload. It shows error stating that wrong boot mode has been selected. The reason is most of the ESP32 boards require the boot switch to be pressed while uploading the code. Now let us try the uploading in the full editor mode. Go to open that full editor and verify the COM port where ESP32 board has been connected. Select the correct board, that is the ESP32 development module, and then click on upload. At the bottom of the screen, first you can see upload started, and then finally serial port and then the COM number. Once you see the serial port, press on the boot button. At the correct moment you have to press the boot button, and then release. Now the code is being uploaded, you can see the percentage, and finally it is reset automatically. So now the code has been uploaded. Go to the main screen. Now you can see the device is online. Once the sketch has been uploaded, you can see online. Unless you upload the sketch, you cannot see this online. This only the skeleton sketch we have uploaded. No, we have not yet completed the sketch. We are going to control LED at GPIO 23, which is pin number 37. So go to the sketch tab, and then we add a constant byte. We name it as LED underscore red, and then provide the GPIO number, which is 23. We are going to control the LED at the GPIO 23, which is pin number 37. And then we, under the void setup, we declare it as output using pin mode function. As LED is output, we declare it as output, and then scroll down to go to the on change function. Here we write the actual code. Void on LED switch change. In this function we use the boolean variable we created. We created a boolean variable LED underscore switch. If that variable is changed, that is if that boolean is true, then we use the digital write function to make the GPIO 23 high where LED is connected. So LED will be on. If you want, you can add the serial.println one comment you can add. Else you use the digital write to make that LED off using the low boolean. Now upload the sketch, and once you see the serial port COM at the bottom, you press the boot button. Press and hold the boot button. Then only the code will be uploaded onto most of the ESP32 boards. Now the code is being uploaded. Once the code has been uploaded, now you can connect the LED at GPIO 23, ground pin to through a resistor, and long pin to GPIO 23. Now from dashboard, let us create dashboard widgets. Click on add. There are very limited widgets as compared to Blynk, but it is sufficient. First we add the switch widget, and then to the right hand side we provide the name for the widget. Let us name it as LED underscore switch, and then we have to link the variable to the widget. Click on the link symbol, and you will be taken to the variable list where you can select the LED underscore switch and then link the variable, and then you can show the thing's name on the widget. You click on OK for that, and finally done. Now the widget is on the canvas. You can use the eye symbol to see whether it is working or not. You slide the switch on, the LED is on. Off, the LED goes off at GPIO 23. So it is working on cloud. Now let us go to the add, and then add another widget, which is slider. This is for PWM effect of LED fading effect, and name it as LED underscore slider. Click on link variable and select the variable as LED underscore slider, which is the second variable we created, which is integer, of boolean type integer. Show the thing on widget, thing's name on widget, and variable range, let us select it as 0 to 254, as we are going to use 8-bit PWM, which is up to 255. Let us select the range 0 to 254. So the second widget is ready. You can click the direction symbol. You can move the widget on the canvas, and if you want, you can put a lock symbol so that the widget is not moved. Also, you can click on the mobile view and then move the widgets as per your requirement. Once the widgets are added, click on done. Now you can click on the eye symbol to see the widgets in action. We have not yet connected the hardware and completed the sketch. Let us do that. Let us connect an LED at GPIO 22, which is pin 36. That is the second LED. First LED is just on off switch. This LED is for PWM, GPIO 22, pin 36. And then go back to things and click on sketch. Let us complete the sketch. Here we'll add that is using constant byte. Let us declare that GPIO pin 22 as LED underscore slide using constant byte. And then we make it as output, that is using pin mode. Let us make that GPIO pin as output. As ESP32 does not have this analog write function, we'll be using LED-C attach pin. LED-C attach pin function, and then the GPIO pin, which is LED underscore slider, comma 0. 0 is PWM channel. Totally 16 channels are there, 0 to 15. Let us use the 0 channel PWM. Next is the LED-C setup function, which takes three parameters: 0, 5000, 8. 0 is the PWM channel, 5000 is the frequency, and 8 is the bit. And let us go to the on LED slider change function and use the LED-C write, and we use the PWM channel and the GPIO pin, these through two parameters, so that the value is applied to the GPIO pin. Finally, click on upload. The code has been uploaded. Go back to the dashboard and you test the slider. Vary the slider. You can see the value is varying from 0 to 254. Accordingly, the brightness of the blue LED changes. 254 is the maximum one, it is full brightness, and 0 is off. Now let us use the mobile app. Go to your Android mobile. There are mobile apps for both Android as well as iOS. Install the Arduino IoT Cloud using the same email ID you used to open the account. Now you get the ESP32 IoT, our application. Open that, you get the dashboard. You can switch the first LED on and off, and then the second widget, slider widget, you can slide it and you can see the change. Let us change the LED from blue to red so that it is clearly visible. So the slider, if it goes to 254, it is full brightness. When it goes to 0, it is off. So the slider is also working and the switch is also working. Now let us go to the add widget and let us add the final messenger widget. Provide the name as messenger and then click on link variable and link that variable to the message underscore ESP, which is the that is a string variable. This messenger widget acts as a chat window between your dashboard on PC and a dashboard on your mobile. Whatever you type on mobile appears on dashboard, and whatever you type on dashboard appears on mobile. Next we'll configure the relay board so that we can connect the actual devices for home automation. This is actually a low enabled relay board. When a low is applied to the input, the relay will be on. The pins are 5 volt, ground, IN1 to control first relay, IN2 to control the second relay, and the output can be taken at the relay contact screw pins, blue pins. We'll be connecting this AC bulb. It has got two wires. I have just taken out the wire, split up the wire. The red one is the phase wire. I am cutting the wire so it can be connected to the output. That is, the relay contact has got three contacts. That is, one is the center pin, one is the normally open, other one is the normally closed. We'll be connecting the load to the normally open pin always, and phase is connected to the pole pin. So you can see the three terminals. We'll be using the pole and the NO. Center one is the pole where we connect the phase of the AC 230 volt, and to NO we connect one end of the load, which is the light bulb, one end of the load is connected, other end of the bulb is connected to the neutral. So when the relay operates, the switch closes and the phase reaches the bulb. This is the concept. So the wire towards the bulb side goes to the NO pin, and the wire which is cut from, that is towards the main side, goes to the C, that is a common pole. Let us connect it this way. Be cautious while handling the high voltage. Ensure that it is switched off. And for V in, at V in pin, that is at pin 19, we can get the 5 volt. As the relay board is 5 volt, let us use the V in pin. The 5 volt is connected to V in, that is VCC of relay board, ground to ground. And IN2, we are going to control the second relay. IN2 is connected to GPIO 23, which is pin 37. As it is low enable, if you provide a ground to the IN2, the relay will operate. Now let us go to the dashboard, that is a sketch, and then modify the sketch. So we'll be using the first one, that is a GPIO 23. Let us leave it as LED underscore red itself. But first we have to make that as high. So we use the digital write and then we make the GPIO pin high. As we are using low enable relay board, first initially it should be off. So make it as high. And under void on LED switch change, we make the if that boolean is okay on, we use the digital write to make it as low. So the relay will be on and finally the device will be on. Now let us check it. Provide the AC supply and be very cautious. High voltage will be on the relay board. Open the mobile app. Now you can see the LED is on as you have initially provided high. Now switch on touch on the LED switch. The device is on, and again touch on, device is off. So the app is working perfectly. Thank you for watching.